Yesterday we worked with reviewing what we had done in Chapter 1, Section 9 on graphing transformations of quadratic functions. Today we're going to start with a small review of that, but then we're going to go the other way around, where if I give you the transformation, you need to be able to tell me what the quadratic function g of x would look like. So one of the things we're going to start talking about today is critical point. And I've used this term before, but we didn't hit up too hard on it. So let's refresh our memory on what a critical point is, which is the point at which a graph of a function changes direction. In a quadratic function, that will be the vertex of the parabola. So moving on to transformation review, we have here this parent function f of x equal to x squared. And the new function that I have here is g of x is equal to 3 times the quantity x minus 6 squared. So first we need to talk about the rule. And I see that I have two different transformations here. And I'm going to deal with the one out front first. It's outside, therefore it means it's vertical. And it is a 3, which is bigger than 1, therefore it is a stretch. And it is a 3 in vertical x just like it should, so it's a vertical stretch times 3. And the minus 6, it is inside, so therefore that makes it horizontal. And it is minus, which we have to think the opposite, so it should be thinking plus, which would be right. It's a translation, so I'll put translation or shift, and that is going to be to the right 6. So knowing that, if I want to write my rule now, horizontal right 6, that means I'm going to take x, I'm going to add 6 to it. And for y, it's times 3, so I take 3y. So knowing that, I'm going to take all my x's and add 6. That means that negative 2 plus 6 is positive 4. Negative 1 plus 6 is 5. 0 plus 6 is 6. 1 plus 6 is 7. And 2 plus 6 is 8. And then I have to triple all the others. 4 times 3 is 12. 1 times 3 is 3, 0 times 3 is 0, 1 times 3 is 3, and 4 times 3 is 12. So now I'm going to go ahead and graph this. I've got 4, 12, which is actually going to be up here. And then I have 5, 3, and 6, 0, 7, 3, and 8, 12. So then when I graph this super skinny parabola, that is what I get. So now I want to do the domain and the range. We know that the domain for the f of x, from what we've done over and over again, is all real numbers. The range is y is greater than or equal to 0. One of the things we also have talked about already is that nothing we can do to this, from the parent function to this function, will change that domain. So for g of x, it is still all real numbers. And then for g of x, it still bottoms out at 0, so it is still going to be y is greater than or equal to 0.